Welcome to the Crazy Wisdom Podcast. My guest today is Christopher Canal, and he is the co-founder of Equistamp. Welcome to the show.
Thanks. Glad to be here.
So, evals. What is your take on evals?
Well, I think evals to me are the most important thing that you can be doing right now if you care about AI. Uh, there's this a ton of hype in the field right now, and I feel like a lot of uncertainty about the future. We don't know when AI will be able to do all white collar jobs. We don't really know even how to measure intelligence or general competence. Um, So what I'm focused on is helping companies and governments build evals that cover the long tail of things that AI can do, figure out what's safe, what's dangerous, and hopefully help people find out when they need to start using AI or when they need to worry about their job being automated.
Long tail. I mean, isn't that long tail infinite?
Oh, for sure. Yeah, undoubtedly. I don't know if I could prove that, but it certainly feels infinite. That being said, there's like many white collar jobs, especially white collar jobs that are being done remotely right now, where you can basically quantify and make little test environments to measure how well agents do it every task in that job.
So, and have you built an agent that you interact with that you have found useful, either at Equistamp or within your own personal life?
Um, I'm I feel like I use LLMs a lot and I don't use agents very much.
Yeah.
So I would say no. So the company that we do most of our work for is Meter, um, and they've they have a framework for creating agents, and they've made a dozen different ones.
Mhm.
Those agents are really interesting. They can do things like play games and
Mhm.
uh, do AI R&D and run experiments and spin up GPUs, do a whole bunch of
Wow.
like computer science type labor. Um, but yeah, I mean, I'm still in my personal life, I'm using LLMs every day a lot to just help check over code, help check over emails, learn things. That's probably actually my main use case is just learning things very rapidly.
Well, same for me, and I love it. It definitely is augmentation. I went to Cerebral
Mm,
Valley, which is the conference in San Francisco, which you may be aware of, maybe my listeners who might not know where it was. And it was so interesting to me because everyone was like agents, agents, agents. Everyone were
yeah,
100% sure that agents were going to take over, but
yeah.
nobody could tell me what an agent was. Um,
Ah, okay,
so, and let me give you my understanding of an agent, and we can
okay.
work from there. So, I had a realization that Perplexity is an agent. It's an information-seeking agent. So it goes out on the
Mm,
web. So it feels like there's one
yep.
agent right there that I've used, and then you mentioned something other, which is computer science, and it feels like those two agent fields are the here right now. Then there's a
Yeah, yeah.
whole bunch of other agents all within uncertain fields in the long
Mm,
tail that feels like
yeah.
they're going to fail. Do you agree? Do you disagree?
Oh, um, I guess I'm just thinking about things a little bit differently than that.
Go for it.
Uh, I guess, okay, so I, I think for my distinction of what an agent is, it has nothing to do with competence or
Mm,
being able to do things necessarily.
mm,
So you can have a really, I would consider a thermostat, for instance, an agent.
ooh, cool.
It's the thing that makes it an agent is that it's operating within a loop, interacting with the world in real time. So the real important distinction between the LLMs and an agent is just a loop. So
Beautiful.
that means it's like you can make an LM into an agent by having it self-prompt or having some scaffolding around it that's allowing it to interact with the internet. So if it's pulling a page, reading all that page, and then you give it scaffolding so that it can choose actions based on the content of that page. So things like there's a lot of LLM APIs that allow you to have structured responses, like JSON responses. And then if it's structured and it has something like weights for each action that it could possibly do on that page, you can have a very simple internet
Mm,
navigating agent. There's I would say that's probably like the simplest LLM type agent that I've seen. It gets much more complex the more you try to let it do. Like for instance, you
yeah.
could
Okay.
use I've seen ones that use like Twilio API where they're making phone calls and sending text messages. That gets pretty crazy pretty quick, and there's not many rules regulating this sort of thing. So like this is something we're worried about and we're testing right now
Yeah.
is like how easy is it for scammers to use something like that,
Yep.
an agent like that to, fool a bunch of people into giving out their credit card information or other
Which is
things
already
like that.
happening, which is already like
Oh
that.
yeah,
That
yeah,
is real. That is happening. That's the main risk. That
yes.
is that of all the fantasies that we engage with in this sector, that one is not a fantasy. That is a real thing that grandmothers need to be trained against, basically. Yeah.
Yeah, yeah. I've had talks with every person. Actually, I'm realizing I've been a little bit ageist about this. I've talks with everyone who's over 50 in my family, but maybe it's time to start talking to people like
The
my
younger
sister who's
ones.
in her 20s.
Yes.
Yeah, yeah,
Interesting.
because I'm like, yeah, because yeah, this is another point about agents. When you're thinking about like who's going to fail, who's going to succeed, there is value in having scaffolding set up where you can just switch, like say you have an agent that's based on the open AI API.
Yeah.
If a new model comes out that is now suddenly much more competent and you already have all this scaffolding that allows your agent to be an accountant, to use QuickBooks and all that, like that new API, if you have an evaluation set up to see how accurate it is compared to human accountants that use QuickBooks, you can quickly see the day that OpenAI releases that new model if it's better than your average human, and therefore if it's now time to release your product to the public. So you can definitely get a lead by having these scaffolding set up. And I would say most of the scaffolding I've seen that turn LLMs into agents, it's quite easy to switch which LLM backend you're using. Does that make sense?
Yes, it does. I got most of it. I think I got enough of it to ask. What I'm getting is that the infrastructure, the scaffolding is the key thing that's not built yet, that should be built, or that people are building. That's where. Is there anything else besides the scaffolding that agents need in order to be successful?
Um, yeah. There is a few things. I think. Well, this is very speculative.
Yeah.
I guess I'll start off with the things that I know, and then I'll venture into what am thinking for the future. The things that I know is that uh, with some evals we've run with Meter,
Yeah.
we've noticed that tasks that have a long time horizon, things that take a human a long time, uh, models do more poorly at. We think this is because there's a if something requires breaking things down into many steps, executing those steps, aggregating
Yeah.
the information you learn from those steps, and maybe there's some branching. One step, if something happens, then you have to go down this path. And uh, it's just there's a lot of opportunities for an LLM type agent to get tripped up, to get stuck in loops, or to get stuck in pointless rabbit holes. And so
Mm,
the longer time
like
horizon you
myself.
go out,
Just kidding.
yeah, I mean, like all of us, really, yeah. But when you really get like 8 hour plus tasks for a human,
Wow.
around that time, a lot of the models drop off in performance significantly and are unable to complete things at the same level as a human expert doing the same thing. Um, yeah, the examples that we have of this mostly have to do with machine learning tasks. So things like training an autoencoder for a very specific data set or problem to do something, or finding optimization on a GPU. So like
Wow.
maybe a PyTorch neural network has some kind of like inefficiencies that you can speed up with just a few lines
Wow.
of code change. But a lot of times, if it's a very big neural network, there's a long debugging loop because you have to load everything onto a GPU, you have to set up a cluster. And so you can have these like sort of simple problems, but they have like long time horizons
Yeah.
because there's like a bunch of debugging steps and things are finicky. And the LLM agents break at those. So I think I think the next set of models like O3, which we're going to get in January, are it's everything indicates that they'll be much better at this. these kind of longer time horizons. Um, yeah, and then I think personally, this is speculative and I don't have much evidence for this. Uh, I think that we'll need LLMs to be trained on data that has information about physics, like
Oh,
actual like paperclip dropping physics, where understanding how the
oh,
physical world works and objects work. It seems like I've seen some evals where simple problems of, oh, this is on a desk and the desk is on a train, things are moving, uh, where the model gets like things that a child would get right wrong still. Um, and it to me, it feels like in order to have a loop where you're interacting with the real world, you have to have some experience about object manipulation, about how things move around the world. So I have a feeling that that's like you can't just have a knowledge LLM based agent that's really doing all the jobs. Like I think there's something maybe missing if you don't interact with the physical world.
brilliant. And this is what I've understood about Jan LeCun's take on LLMs. And he says that it's essentially not the final form, and that a final form
Mm.
need to be some sort of world model.
Ah,
Yeah, and like we can talk about all the other potential algorithms, because for those of my listeners,
mm.
LLMs are one algorithm within the general domain of machine learning, and we have computer vision. And I imagine the computer vision, there's like a lot of different algorithms in the computer vision. We also have a
Oh
bunch from
yeah,
Microsoft before LLMs came that helped traders do crazy stuff. Um,
yeah,
Anything
yeah.
to add there? Anything to add about that general world of
Oh,
machine
well,
learning?
I guess
Yeah.
yeah. Starting with Jan LeCun,
Mm.
I think there's definitely evidence that he's wrong about that. So
Mm.
the algorithms, what we've seen is that scaling laws apply no matter if you're using transformers or LSTMs or any other
Oh,
algorithm.
interesting.
If you have more compute and more data to throw at it, you can get to approximately the same performance. Um,
So it's that bitter lesson
it's
again.
Yeah, yeah. It's not known exactly why. And I'm not saying that like any algorithm, like like you can't scale up SVMs the same way that you can scale up neural networks. But
What is an
I'm
SVM?
saying that like support vector machines. So it's something that's very similar to neural networks that kind of predates and was used on the same sorts of problems in computer vision. Um, but I digress. The point is that I have an intuition about this, and my intuition is that Jan LeCun's right, but the evidence to me is showing that that doesn't matter. That there's not the algorithmic improvements aren't as important as getting more GPUs and more
Wow.
data. I would say that my intuition comes from just you and I and observing how our brains work.
Yeah.
Uh,
But maybe it's totally different.
my
Yeah.
yeah,
Yeah.
exactly. So here's the weird thing. A GPU cluster to that the biggest models run on takes orders of magnitude more energy than your brain,
Mm.
but your brain is more capable. So obviously there is some you know algorithm or something where that it's much more efficient, right? With less energy, it can do the same sort of thing. It's right in front of me, talking to me.
What
So my intuition tells me that there is some improvement we can make to these algorithms where it the neural network that's running is as efficient or more efficient than our brains. That being said, there is like another thing that's kind of blocking that, which is that if you think about it, like how did your brain get here? Well, it's through millions of years of evolution. And that evolution you could think of as maybe the training data for building your brain.
Mm.
It's not just your life experience, it's everything that came before because your genes encode a lot of sections of your brain to do certain things. A lot of the structures there, um, and then there's some like additional learning that happens after you're created. So I think that if you consider the amount of energy used in evolution to get to your brain, it's orders of magnitude more than we spend in training data and training runs with the large models. But if we think about the actual time that you're running, right now you are using way less energy than the biggest models. So Yeah, it's kind of confusing. Part of me thinks that like there is some optimization where the model should be much smaller and perform better. Um, I'm not sure though if this is a limitation of our current hardware and the way that we're building that hardware and then building models on top of that, or if this is like there's like one crazy algorithmic improvement and now you have something that takes 10 times less energy than you, but is as good as a language model.
So this reminds me of an interview I did with Subutai Ahmed, who is the CEO of Numenta, which is started by Jeff Hawkins. Jeff Hawkins was,
Yeah,
yeah,
Palm Pilot
yeah,
guy.
Palm Pilot, exactly. And if you know that, I would love to talk about the history of what we're getting into, particularly in terms of values. But the point that Subutai gave me is that the brain is either 20 or 40 watts, real time, no batch processing. What we have right now are batch processing, large compute, inference. And but I like what you're saying here is just maybe it's all wrong. Maybe it's like maybe we don't even need to use the human brain as the example. And this gets into
Yeah.
ethereal, speculative notions on the brain and consciousness, and what is the relationship between the brain and the consciousness, which I don't think we know. I don't.
Mm,
I don't think we know that. I think we know some things about the brain. I think we know a lot about the different type parts of the brain. I don't think we know emergently how the brain creates
mm.
consciousness or is interwrapped with consciousness. What do you think on that?
Oh yeah. Oh gosh, I feel like I kind of want to say something maybe controversial
Hmm.
here, but um, I don't think for the things I personally care about, consciousness doesn't matter that much. I personally enjoy thinking about consciousness
Yeah.
and reading about certain theories. Uh, that being said, I guess I'm much more concerned with competence. I like to imagine or this like Chinese room experiment where you can put you put messages under the door and things can come back perfectly to convince you that there's a person under there, but really it could just be a guy who doesn't even speak English.
Or an LLM or whatever. Yeah.
Yeah,
Yeah.
putting things into a machine that look up the response and then he just sends back the response. So if you have a huge library of possible things that could be asked and things that could be responded to, um, and the question is like, is this machine conscious if it's so perfect at giving you these responses, maybe of uh, a dead relative or something? And I believe no, it's not conscious. It's just a
Yeah.
regular
Yeah.
machine,
Yeah.
just as conscious as a library is conscious. Um, but that being said, like a machine like this can destroy the world or change the world for the better. It could give you the cures to cancer or the cures to aging, I think. And that only depends on how good the machine is, how competent it is at solving certain problems, at achieving certain goals. So I don't think about consciousness that much because I'm just so focused on evals and trying
Yeah.
to measure and predict the future of AI.
And I agree with you that it is valuable to study only in order to remain grounded among the calls of essentially saying that this is a sort of life form that we've created that we know is conscious. And so I agree
Mm.
with you that like it doesn't really matter. Uh, well, and we could go into evals and how to do evals for consciousness, but I think the philosophers already kind of are right in the sense that we can't do it even for other human beings. I'm not a
Oh yeah, yeah,
solipsistic, but I
yeah,
think
yeah.
they're right in the sense that this has been they've been talking about this for thousands and thousands of years, and we still don't know what consciousness is. But so let's go back to competence and evals.
Mm.
Can you describe the current state of evals as it relates to evaluating truthfully and honestly what these things are doing?
Yeah. Yeah, I would say that I think evals are a real shit show right now.
Yeah,
This is why I think it's important to work on
to do
them.
it. Yeah.
Uh, the main problem with evals is data leakage.
Mhm.
What that means is we are writing crawlers that get information from the web. And once we have that information, we use it for training. And there are some different companies have different amounts of like filtering out things to try to make sure that we don't train on certain things that we don't want to train on. Maybe you filter out a bunch of racist stuff from Fortran, or perhaps you actually have your own evaluation that measures something you care about at OpenAI, and you make sure that that evaluation and no information about it gets into the training data. But it turns out that this is actually extremely difficult, extremely, extremely difficult. And what we're seeing is that now we're on about a 3-month cadence of releases from the major LLM companies. And that means that only the data on the internet within the last 3 months is safe, meaning that if you've released an evaluation and other people have access to it, then it likely gets sucked up into the training data. And I think this is mostly through forums where people are asking about different question or different things in a particular evaluation. But sometimes I suspect that it could even just be a raw text file sucked up into the training data somehow. Really unsure about that. So what that ends up causing is a lot of companies to be overconfident in their models because it actually just memorized some evaluation versus it being withheld and then a fair test. You think about this like if you gave a kid the exact SAT they're going to take in a week from now, it was the exact test. Many kids would resort to memorizing A, B, C, D because it's just the densest possible, or maybe not the densest possible, but it's one of the easiest ways to memorize. And so we're getting the same sort of thing where we're just giving the SAT test to the models. They train on it, they memorize it, they go through it 100 times. And then when you ask them those questions at eval time before you release to the public, it's essentially just looking up the answers in its memory and the weights.
And this will going back to the agent conversation, this will heavily cause a problem for the agent. Like it feels like they will just know the answer to the question that the eval is giving them. Is that right?
Yeah, that's exactly right. A lot of most companies that are maintaining evals are resorting to keeping a set of those questions extremely private. I think that in most cases, there is something to getting used to a particular test. So for instance, I mean, we can use the SAT example again. There are certain kids that take a class on how to take the SAT well. And I think this is a version of good harding, where are you familiar with good harding? Actually, should I explain that? Oh, yeah. So you've probably heard it before, but Goodhart's law is once a measurement or metric becomes a target, meaning it's something you're trying to achieve, it ceases to be a good measurement. So this is just like, SAT originally, it's supposed to like help you rank different students for competence, scholastic competence. But once you've had it out there for a while, all these classes, get created on how to take the SAT, and maybe someone even finds out, oh, it looks like for some reason C happens 30% of the time instead of 25%. So you can, if you're between two answers and one of them C, you can default to that. So that's just messing up the signal, right? It's muddying the signal with a bunch of other things, and you're not having a clear measurement. I think that putting out your eval on the internet, and then even if you're withholding a few test sets, it increasingly gets good-hearted. The longer it's out there, the more people talk about it, the more it gets sucked up into the training data, to where eventually you don't have any signal left, right? It's just your signal to noise ratio is off, and you don't know what this measurement means.
Man, I love it. I love this interview. So let's go to competence. So forgetting everything we've learned about since AI showed up on the scene, maybe even before computer vision showed up on the scene, what is competence and how has it evolved, ever since 1945? But, we can go even further than that. If you're a student of this historically, what is competence? How do we define it? What do we know about it?
The simplest way I could put competence is it is how well an agent achieves a particular goal.
Hmm.
So I know that's pretty broad.
Yeah.
You could you could define things as like, oh, well, my goal is to be conscious or in control of my
Yeah. Yeah.
consciousness,
Yeah.
and things get kind of confusing there. But a lot of times, we have personal terminal goals, and we have a bunch of intermediate goals that get us there. So you might have something like a terminal goal for you as a human might be
Oh.
I want my children not to die. But your kind of intermediate goals might be things like make sure they get vaccines and make sure I have enough money to put them in, live in a country where it's safe. Uh, yeah. So if in the case of the goal of like your children not dying, you are competent at that if your children maybe don't die. I I think for work tasks, you have things like an accountant may want to make sure they classify a bunch of different expenses correctly and also find different tax loopholes, some of which may be, fairly complicated. So you might have something where you measure the accountant's competence by how much tax savings they provide a particular client, given the information they have access to. So competence can be defined, it's different depending on the goal. It's kind of like there's not really a one size fits
Yep.
all.
Yep.
I don't think you can do something like IQ with the models. It
Have people
doesn't.
tried? Are people trying that?
Oh, definitely, definitely.
Uh,
Have you heard of there's a eval by Francois Cholet.
no.
Do you know who that is? It's a
I've heard
Keras
of
creator.
Francois Chalet, but I don't know.
Yeah. So he created Keras. He's a vocal. He reminds me of Jan LeCun a little bit. He's kind of an
French.
anti-doomer, this version of
Great.
AI sucks type person, even
Uh-huh.
though he's been one of instrumental in creating it. And he was so annoyed with all the different evals, like math tests, and saying like, "Oh, it's scoring better than the average human at these math tests. It's smarter than humans." So he created a basically an IQ test for LLMs. This IQ test is very similar to these sorts of IQ tests that maybe you've seen, where it's like you have a pattern of different, maybe there's like a grid of 9 different images, and you have to predict what the ninth image is given the other 8. So his eval is very similar to that. And originally, it had this quality that we really like in evals, which is where all the models score super low, and then an average human scores very high. So in that case, you're identifying something that the models haven't learned to do yet. And so that's usually interesting to a lot of us. However, I think I guess a week ago, uh, OpenAI announced that they've beaten his
Yeah.
evaluation. They've
Okay.
beaten the human performance.
Yeah.
So we don't know if that's true because I haven't. I've applied for access. Meter has applied for access, or my clients have applied for access, and I'm not aware of anyone that has access yet to verify this claim. But we will be verifying it hopefully in the next couple weeks. So
That is so interesting, and the competence is so interesting for me because I have been learning a lot about meritocracy and the idea of
mm,
meritocracy. And
mm,
I thought meritocracy was I went and looked up the etymology of meritocracy, and I thought it was like a long-standing concept symbol inside of Western civilization. But it turns out it was invented in 1958. Although Thomas
mm,
Jefferson did talk about a sort of the group of people who could essentially a talentocracy, I think it was called. But
mm,
meritocracy was a word invented by Michael Young, who wrote a novel called
mm,
Meritocracy, and it's a satire novel. It's a satire novel about what was going on from 1945 to 1968 with the rise of the American empire and Robert McNamara, essentially these really, really smart technocrats who essentially ran into problems. And it's directly relevant to where we are today with evals because
mm.
now we're not dealing with human distributed cognition in the form of really smart people who are doing really interesting work, but also dangerous work, nuclear power, all these different things.
Yeah.
And so we're now in a realm where we have a artificial intelligence that's now entered the scene, and
Yep.
nobody knows how it works. And I want to make sure that I want to make the last 10 minutes where we go into Equistamp, but this like we don't know how it works, right?
Yeah.
It's a black box, and we don't have neural, there's a word for each neuron, what each neuron is doing within the neural network.
Yeah.
Would you know that word? But at both levels,
So
high level, yeah, go
the
for it.
the
Yeah,
this field of like figuring out what each neuron or groups of neurons do is often called mechanistic
that's
interpretability.
it. Yeah,
Yeah. So we don't know how we should interpret
yeah.
what this particular neuron is doing given many different inputs and outputs. Um, yeah, I think I would consider in that field Chris Olah to be leading the field. I've loved everything he's written. Highly recommend
How do you
him.
spell that?
Uh,
Chris
uh,
Ola?
Chris Olah, Olah. Yeah, so eh, this is pretty critical, right? If we had tools that were accurate enough that we know when an agent is lying, or
Oh,
when they're in an internal loop and they're planning things, if we know that they're planning something that we don't want or that goes against our general uh, concern, general wishes, I think that's a early warning system that could be quite useful. Um, yeah, so you want to hear about
yeah, yeah,
Equistamp? I
yeah. Tell
mean,
me.
we've basically
Yeah,
been talking about it the whole time, but
yeah.
yeah, I started Equistamp with my co-founder Daniel O'Connell a little over a year ago. We'd been working on an AI safety chatbot to help educate people about AI safety, and we knew we wanted to do something in evals, and we felt that most of the companies that are concerned with AI compliance, AI safety, and the future are nonprofits. And we
Whoa.
thought, what if we made a
Yeah, I like it.
for-profit
Yeah,
company
yeah, I
where
like it.
we can only do things that are, we'll commit to doing things that we think are safe, but also we can measure how much value we're actually contributing by having a for-profit and having money come in. I think a lot of the nonprofits, and I won't name names, but there's a lot of AI safety nonprofits that I think are in that sort of diving into a rabbit hole that may not be useful,
Yeah.
maybe too theoretical and not producing software that's going to help actually
The
regulate
problem, the
things
big
or
problem.
yeah. It's not producing the thing that's going to fix things. So I'm hoping to be part of the solution and actually putting possible solutions forward that help more than they hurt, which is difficult. We've definitely had to say no to many projects because we want to be AI safety focused. Um, Most companies that have come to us and asked us to help them uh, build some sort of evaluation system, they want they also want us to help them build training data to help them train a specific model that's going to help them automate a bunch of their employees or uh, be cheaper than their
Yeah,
competitors.
interesting.
Yeah, some of the companies are like AI girlfriend apps,
Yeah.
things like that, where it's like the things that they're wanting to do go against what a
Your
lot of my
core.
employees, yeah, our core values. Um,
It's so
yeah,
interesting.
I think,
That is the I'm not sure if you've read any Nick Land, but Nick Land is very, very appropriate for this conversation at the
yeah.
moment, which is just like the nature of capital. I disagree with him on a lot of things, but the nature of
Mm.
capital finds value, and really right now, where is all the value? Value is the scammers who are using these things to scam people, and relationships. What is it? Parasocial relationships with the AI, and that feels like a dangerous, dangerous thing. But
Oh
it
yeah.
feels like it's going to happen. But this is where individual choice comes into the thing, and we don't have to go into that. But so okay, so we've got these companies. The primary problem I see with the evals as they currently are is that it's the foundational models speaking their own book. So they're doing
Mm.
evals, and of course those evals come back looking like they're great for the companies, and they
Yeah.
might be great, but they're also speaking their own book, which talks about
Yep.
the principal agent dilemma. And the principal agent dilemma is essentially like if I hire a lawyer, that lawyer is acting in my interest, hopefully, but they're also acting in their interest, and it's very
Yep.
difficult to trust that person specifically. And
Oh
I
yeah,
feels
yeah.
like that is the main problem that you're working with is the principal agent dilemma, how to provide third party, like actually tell them when they're wrong, how to tell a client when they're wrong. What do you think about all that?
Well, I think what you're referencing, well, what it reminds me of is a lot of clients, they just come to you and they're like, we want to use ChatGPT, and we think the customer support center at our company sucks. We just want to use ChatGPT. We
Yep.
think it'll be better. And this is a place where it's like, whoa, not so fast. That might be true, but we don't know, and we can increase our confidence
Yeah, by
by
yeah.
by having an eval, having a system that measures these
Oh,
things,
cool.
and having a human baseline. So
Human
if we
based.
have,
Great.
yeah, meaning we measure the people and how they're performing their job, how they handle debugging issues. If it's customer support, it's like how satisfied people are with interacting with that person. Um, and then once you have that, you can create a sort of matrix of this is how much satisfaction these people got from interacting with the humans versus the AI. This is
Mm,
the number of mistakes we're classifying. And then we have a cost for each, right? Because using the APIs, it's not free. And sometimes it can be extremely expensive.
mm.
And something to consider is that some people, depending on where you hire them, are extremely affordable. So oftentimes you're getting a
Yep.
small degradation in performance to switch to the LLMs, and you have a whole bunch of scenarios that those LLMs aren't great at handling. Um, and you're only saving, maybe 30% or something.
Yep.
So like sometimes it's just not worth it. And when you have that matrix, you're like, oh, these problems, these errors end up costing us, $10 per error because we end up just having to refund a customer their full,
Yeah.
subscription fee or
Yeah.
something.
Yeah. Yeah.
So we try to provide, or we do provide this sort of setup where we're going to have an interface for your employees. We're going to create evaluation data that's measuring the exact thing you want, as few proxies as possible, and then we're going to show you the cost benefit trade off.
Yeah. Cool.
Another thing that a ton of clients have is privacy concerns. So this means they don't want any of their data going to OpenAI at all. They don't
Mm,
trust the terms of agreements or whatever, and they want to get some open source model like Llama and train it and use it
that's
locally.
interesting.
And yeah, it is pretty interesting, and it's not unfounded. And in fact, I'll say Percy Lang's lab, which is a Stanford NLP, released a paper, I think yesterday, talking about cache hacking or cache sharing. This means that like when you ask an LLM a particular question, like maybe you ask when was Obama's birthday, there's a system that looks for if that string has been sent to the model before, and rather than using all the expensive GPUs and stuff, it hits the cache and it sends back the response. They created a method where they basically a timing attack, which means you look at how long it took each response to come to you, and then you can pretty strongly infer when the cache was hit versus when you hit the big GPU cluster that had to do a bunch of work, right? Because if the cache gets hit, it's much faster.
Whoa.
So they did this work, and what they discovered was that many of the LLM companies are uh, have shared cache, meaning your
Whoa.
cache is shared with a guy who works at Google if he's using ChatGPT. His cache, they're probably not. By the way, it's employees are not allowed to use that. But different. If you're sharing cache between
Yeah.
companies, it's a pretty big vulnerability where someone might get access to some of your data. Um, a lot of I'll say this, they told all the companies in mid October that they were leaking data between organizations, and most of those companies patched this by the
Wow.
release date of the paper,
Okay.
which is yesterday.
Yeah. So they're aware of
Um,
it.
yeah, they're aware of it, but not all of them did.
Mm.
And I think this is like another example where it's like these sorts of vulnerabilities come up, and there are almost certainly other vulnerabilities that exist at these
Yep.
companies
Yep.
that will cause you to leak very sensitive customer data or citizens' data if you're government. And yeah,
It's
this
right.
is this is another thing we're trying to help is
Yeah.
like prevent all these sorts of issues.
It seems like a potential nightmare. Like the internet in general, internet in general has always been a nightmare in terms of cybersecurity.
Oh yeah, it's very difficult.
Yeah, my understanding is that like if a hacker wants to get you and they're well funded and they're well resourced, they're going to get you, right? And
Yeah.
most companies even before LLMs were hacked. And now these LLMs are just it seems almost more vulnerable. This is a good question. How would
Oh
you
yeah.
evaluate? Yeah, is it are LLMs more vulnerable than a database? Depends.
It very
Yeah,
much depends, but
yeah.
I'll say that I think anytime you get a new technology, there's the market is not perfect, right? People do not figure out all the use cases right away, and
Hmm.
as those new use cases come up, new vulnerabilities are highlighted or become more salient. Um, so yeah, I have some ideas about those vulnerabilities coming up, but it's quite uncertain right now.
Hmm. Hmm.
Uh, and
So
I feel yeah, I have mixed feelings about sharing these things
yeah,
because a lot of them, a lot of the things I'm worried about have to do with jailbreaking.
yeah,
And there's some methods that are still quite effective at
yeah,
jailbreaking.
yeah. The
And
more you
this
put
is
it out there,
mostly,
the more people can find it,
it's
right?
an information
Yeah,
hazard.
yeah. It's
Yeah, it's an
information
information
hazard.
hazard. And yeah, so things like trying to create certain kinds of weapons, the models can tell you how to do that. And that's
But
if you
that
jailbreak them.
that
And
already
so,
existed, like I remember the anarchist cookbook when I was like
yeah, yep,
17 or
yep.
18. Like it's all out there already, right?
This
Like
is this is quite a,
yeah.
this is quite a bit different.
Okay. Yeah.
I'll say that like there's a difference between a weapon that can kill, 50 people and one that can
Mm,
kill 5 million.
yeah,
Um,
interesting. Yeah,
and
that's the other existential risk. Yeah. Yeah. Mm.
yeah, yeah. So yeah, I think that's the main thing I'm concerned about. I'm trying to get more companies to be concerned about.
Mm.
Um, but yeah, it's we'll see what happens. Hopefully nothing bad.
So how can our listeners find out more about you and your company?
You can go to equistamp.com and yeah, you can subscribe to see. We have features that allow you to get alerts when models surpass certain performance. So if you're worried about maybe your job as an accountant and you can see human performance on different tasks as an accountant, you can create a little notification. Uh,
That's cool.
Perhaps also, if you want to use things like ChatGPT to help you with your job, you can know uh, when and
Yeah,
which models you should be able to trust.
that's so cool.
Also, we provide consulting services. So if you're a business and you're trying to use agents or LLMs, we can help you do that safely.
That's so cool. Thank you so much.
Yeah, thanks a bunch.